data. The city of Kyle is considering 4 different methods to survey their city to gauge their support. Particular bond package. Describe the method of sampling. Okay. Survey everyone entering and exit the city hall on Tuesday. So this is not going to work. It's not representative. We call it cluster sampling. It's when you take an existing group of subsets, the represented population, and use it in the sample space. This is not going to give you a representative population to survey. Part B asks the planning department to list all the students whose ID numbers has last digit of 5 and survey those residents. This is actually good data. We call this just a random sample. So a random sample is going to produce a likely to be representative of a good sample space. So when each member of the population has an equal chance of being selected is a random sample. You want to try to get a random sample from the different type of sampling that you're creating. So this is like a good introduction to it's like a good introduction to baby statistics. Survey the residents who live on the street closest to City Hall. In this case, this is not going to work. We call this stratified sample. So the population divided into smaller groups, and the members have characteristics. And then the groups are chosen at random. This is not going to work because this is not likely to be representative of a random sample. D, print out all the lists of residents and survey the first 2 residents on the top of each page. Okay, this is not as organized as this one looks for the random sample, but this is actually a good way to pick out data. This is called systematic sample. So what happens here is you take the numbers of each member of the population and select every nth number, or k number is what they call it. And that's likely to be a good random sample. So it's almost like you're picking like every 5th person or every 10th person or every first person. We're going to assume the same number of names on the page. Okay, because it says print out a list of all residents and survey the first 2 residents on the top of each page. You need to assume, so you need to suppose that there's the same number of names on each page. Applied 4 scholars were classified according to their class rank. Freshman, sophomore, junior, senior. Construct a frequency distribution for the data. Okay. All we're doing is counting. So for the freshmen, you're using green. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we do tally 9, and then the frequency is the same number as the tally, but it's like a written out number, so it's just 9. Sophomores are in blue. For sophomores, I have 1, 2, 5, and then I'm gonna just write that in. For juniors, I have 7, and seniors, there's gonna be 6. Now, your frequency should, when you add them all up, should be the n of the group. So if we count our group, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 2 is 24, 25, 26, 27. So let's see if this n ends up to 27. So this is 14 plus 13. So our n is 27. This should also match your n. Thousands of acres of 39 U.S. national parks is shown here. Construct a frequency distribution for data using 8 classes. So we also call classes a band. We call them an interval. And then from there, we create a width. I'll talk about that in a second. So we have to find out how many we have here. So if I count, I have 4. So this is 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have, it's 3 by 10. So that's 30. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my N is 39 here. All right. The range for each class or the class width. So the range is going to be the high minus the low. So our range is going to be 775 minus 5. Again, we're looking for the range. That's going to be 770. And then the class width. Remember, it says that we want 8 classes, so it's going to be the range divided by the number of classes. All right, so right here is the range. Now, the number of classes is 8. So 770 divided by 8. We're going to get 97. We have to round up. So it's going to be a width of 97. So now we have to construct the classes. So you start from the lowest point and then you go to 97 and then reduce it by 1. Minus 101. And then you're going to add 97. So it goes 102 to 198, 199 to 269. Nope, that's wrong. 199, 296. We're adding 97. This is a dash. 297 to 329. No, I'm mixing my numbers around. 392, 393 to 489, 490 to 586, 587 to 682, 683, and then 684 to 780. And then we just tally however many of these different acreages fall in here, and then again the tally and the frequency number match. So if I just count, this one's gonna be 1, 2, 3, 4, 5. So it's gonna be 17. And this is how we're doing it. I'm just kind of counting by sight. So in 5 through 101, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, this is not right. That's 17 right there. And then we just kind of keep on going. So the count on 102 to 198 is 6. 5, 6. The count on 199 to 296 is also going to be 6. 297 to 292 is 2. 493 to 498 is 2. 490 to 586. 490 to 586. 490 to 586. 1, 2, 490 to 583. Oh no, that one doesn't count. 490, 1, 2, 3. There we go. $487 to 683. 487 to 683. 587 to 683. 1. And then 684 to 780. 1. And then, let's see. 584 to 780. Now that one. And that one, 760. So there's 2 there. And then we want to, again, make sure that our N adds up to 39. So altogether, this needs to be 39 and this needs to be 39. So this is 39. Right? And that's how you find the frequency. Calls made during a randomly selected week as shown here. Construct a stem and leaf plot for the data and analyze the results. So when you have the 12, here's what you're going to do. You have 12. So this is the ones place and that's the tens place. And then we're going to put them in order. So the leaves are 12 because it already counts for the ones place here. And then you're going to look from everything from 20 to 29. So 20 to 29 is going to be 20. And then I want to put them in order as I'm putting them in. And then we have a 23. So this is going to be a 0 and a 3. So it's like 20 and then 23. Next is going to be the 30s. So 30 to 39. I'm just going through them to highlight them. Okay, so I think we can go in order here. I have, how many 32s do I have? I have 2 32s, so you have to account for each of them. I have a 33, I have 2 35s, and I have 2 38s, and I have a 39. Now we're looking for the 40s. I have 41, 43, 43, 44, 41, 42. So that means I have a 41. I had 2 of those. I had 142. I have 3, or no, I have 2 43s. And I have a 44. And then we look at our 50s. We want to put those in order. I'm still going to highlight them. Okay. And we want to make sure that all of our numbers in our sample are accounted for. So I have a 50. I have a 51. I have 3 of those. I have 2 52s. 53. 2 of those. 155, 158, 2 59s. So I got what, 9. Now it says arrange them in ascending order. That's what we did. So ascending means from least to greatest.